Welcome to Week 9's lab lecture. This week we're going to be covering probably one of the topics that at least my on-campus students probably hate the most, and that's a write-up of a proper ECM, or operational and maintenance recommendation. So that's what we're going to be doing this week. We're going to look at a proper write-up, or how an energy conservation measure and operational maintenance recommendation is to be written up. Now, an ECM, which is energy conservation measure, it can also be known as an energy conservation opportunity, and O&M, which is operational and maintenance. These or any recommendation are written with the same format. Now, this format was established by the federal government, because most of the audits I do are funded by the federal government. The federal government sort of dictates the form that they're written in. The format has four main areas in the write-up. They have a recommended action, they have a background, they have anticipated savings, and they have implementation costs. So, Section 1. The recommended action. This section is a brief overview of the ECM, including the energy and monetary savings. This is strategically placed at the beginning of the ECM, so that a building owner can quickly scan each ECM. So this section is put there so a building owner can quickly thumb through, get a glance at a general idea of what's being recommended and what it's going to save both in energy and in money, and they don't have to wade through a lot of grueling detail on how those numbers were derived. Now, at this point, you should note that ECM should be located in the document in order of the least costly or the quickest payback. So when recommendations are placed in a document, usually we put them in order of payback, simple payback. So the ECM that has the quickest payback will be put first, and then the next quickest next, and so forth, all the way out to the longest payback. So there is some order to placing them in the document. So here's an example of that Section 1, the recommended action. So you'll notice at the top, we gave the ECM a number. This is number 1. The brief description in the title block, we're going to replace existing T12 lamps with T8 lamps. Now, this doesn't even give area. It's just a generalized title. And down here, we give a little bit better explanation. We're going to replace the fluorescent T12 lamps and fixtures in the break room with fluorescent T8 lamps and fixtures. And then finally, we have an estimated energy savings. Typically, this is going to be in kilobtu's. We're going to have an estimated cost savings. That's going to be dollars per year. We're going to give them an idea of implementation cost. What's this going to cost out of pocket? And then we're going to calculate a simple payback. So this is under the very first section, the recommended action. And that's the description of the slide, in case you need a recap. The next section, this is called the background section. This section fully described what's currently going on. So it's a detailed explanation of the current situation. We're not going to make any reference to what we're going to do or what's going to happen in the future. We're simply fully defining what's happening right now. So, this focuses specifically on the item that will be recommended for change. It includes the current operating condition it's under and the current cost of operation that we're under. Note that the calculations are shown in full, so someone else can duplicate. So in this case, when we calculate something, we have to show the equation we have to show the full steps in how we're calculating something, so later on, if another professional gets a hold of this document, they can fully follow through how we arrived at our savings. So here's an example, going along with that ECM that we just talked about. The break room area currently has 10 surface-mounted fluorescent light fixtures that are operated Monday through Friday, 8 to 5:30, no hours on the weekends. This is true all year long, so this happens every week. Each fixture contains 4 40-watt, 4-foot T12 fluorescent lamps. These are an old-style T12 fixture with an old electromagnetic ballast that has a ballast factor of 1.25. In other words, the ballast adds another 25% onto the wattage that the lamps have. Using the current utility information, the annual operation cost for the current lighting is calculated as follows. So you'll notice that we divided up under demand, then consumption. So first the demand, I have 10 fixtures, 4 lamps per fixture, 40 watts per lamp, times the ballast factor, and convert to kilowatts. So those lamps, when they're turned on, use 2 kilowatt of electric demand. Then we calculate consumption. First, the hours of operation. If we go 8 to 5:30, that's 9.5 hours per day, times 5 days a week. Every week of the year is 2,470 hours per year. If we take that hours times the power, that 2 kilowatt, we get 4,940 kilowatt hours per year. So this is my demand, this is my annual consumption. So the energy consumed in kilobTUs per year is my kilowatt hours times 4.312 kilobTUs per kilowatt. So I have a kilobTU consumption per year of 16,855.28. This is the background. This is what's happening currently. Notice how I didn't mention at all what we're going to do. It simply is defining what's happening now. To continue the electrical demand cost, we have the 2 kilowatts times 1642 is $32.84 a month. $32.84 a month times 12 months, it's costing us $394.08 a year for demand. The electrical cost consumption, they're paying almost 9 cents kilowatt hour times the 4,940 kilowatt hours. They have another $444 in consumption. So their total annual energy cost is $838.19. So that ends section 2. We described fully what was happening and the cost of what's happening. In section 3, this is the anticipated savings. Now we go through that same exercise and we discuss what we're going to change, how it's going to impact, including the cost. So, again, it fully describes what's being recommended, what will happen, and why it's being recommended. It'll include future operation, if operational hours are going to change, and future cost of operation. Again, note the calculations are shown in full, so somebody else can duplicate. In this case, we're recommending that the existing fluorescent T12 fixtures and lamps are replaced with T8 fixtures and lamps. The following quantities of T8 lamping support this recommendation. So the T8 lamps are 32 watts versus the 40 watts of the existing. So we're lowering the wattage of each individual lamp. The ballast factor of the new electronic ballast is only 0.98 versus the additional 25% from the old magnetic ballast. And the T8 lamps don't impact power factor, which we didn't even bother going into in the background section. So, the anticipated annual operating costs. We have 10 fixtures, again, 4 lamps per fixture, 32 watts per lamp, times the new ballast factor. We now have reduced the kilowatt of demand from 2 down to 1.25. The electrical consumption, same hours of operation, times the lower demand, so our consumption has been reduced. We converted to energy, the kilowatt hours to energy, the kilobTUs have gone down. If we compute that with the same pricing before, we have $246 for demand, $444 for consumption. The annual energy cost $838.19. The cost save $838.19 minus $690.41 is $146. This number right here should be the $690.41. Sorry, I don't know how that ended up the same, but it should be the $690 if we add those two together. It should be $690.41. And we have an amount, $147.78. The total energy saved, if we look at the kilowatt hours and the kilowatts, we have a total of 21,566.33 kilobTUs per year. Finally, in section 4, we have implementation cost. We're only going to implementation cost and simple payback. This section fully describes what the recommendation will likely cost. This includes materials, labor, rebates, salvage values, etc. Again, the calculations are shown in full so somebody else can duplicate, and hopefully they actually do it correct. I must be getting old and senile. Anyway, in this case, the cost, I have 10 T8 fixtures at $128.30 per fixture for a total of $1,283. I have 40 T8 lamps at 98 cents per lamp. The labor for fixture replacement at $28 per fixture at 0.6 hours per fixture is $168. The T12 lamp disposal at $1 per lamp, because they do have mercury in them, so it's going to cost us $40 for disposal at a total cost of $1,530.20. Now, we did some research. There is some rebates and refunds. The magnetic ballasts, if we turn them in, have a salvage value of $4 a piece. That's $40. And the utility company has an incentive of $20 per fixture, or $200. So we have a total refund or rebates of $240, which drops that $1,530.20 down to $1,290.20. Now, once you calculate the anticipated savings of the ECM and the implementation cost of the ECM, you can calculate a simple payback. Simple payback is simply how much it's going to cost you to do something divided by how much it's going to save you a year. Simple payback is a quick way of comparing different recommendations. The lower the payback number, the quicker the recommendation makes a positive cash flow. Again, the longer payback, the less likely a company will do a project. In this day and age, a simple payback of less than 1 year should be done right away. Each company will decide what sort of the max payback they're willing to look at. So the simple payback in our case was the $1,290.20 cost, implementation divided by us saving $147 a year. This has a payback of 8.73 years. So you now have the information to go back and fill in section 1 of the data. So you actually go back to section 1 and you fill in the different areas. You fill in the energy savings. We gave it both in kilowatt hours, a savings in consumption, demand, and energy. We gave the cost savings per year, the implementation costs, and the simple payback. Now in Lab 9, you'll be given the background for a suggested ECM for a building. Now this is an actual building here in Big Rapids. You will use Lab 9 form and fill in the appropriate information for an ECM. You need to take your time. Make sure you sort out the information correctly. You will attach the form in the lab for grading. This ends Lab Lecture 9. I apologize for my math problems. Probably isn't one of my strong suits. Anyway, you now can proceed to Lab 9. Thank you.